Okay, right. My mission is to try and encourage you to look at doing something you may not have been doing before. For me, this echo's too loud. You sure? Okay, fine. So my mission is to try and help you do something that you may not have been doing before, which hopefully will improve your testing and streamline it. I've decided to introduce the topic of analytics before helping you understand a little bit about how to apply it, because I suspect that most of you know relatively little about it. The material is Creative Commons, which means that you can do more or less anything you want with it, apart from claim it's your own. So if you want to use it yourself, if you want to teach from it, it's all fine by me. First thing then is symbiosis. What does this mean? There are three types of symbiosis. The first is parasitism. Now, for those of you who don't know what a head louse is, lucky you. If you haven't kids, you probably realise, but they're a parasite on you, and they have a symbiotic relationship with you. Unfortunately, you suffer. Commensalism says that one side benefits, the other one is neutral. We have a hermit crab who's living inside a snail shell. So the snail doesn't benefit, but the hermit crab does. Mutualism is when we both benefit. So in this case, we've got the wildebeest and we've got the zebra. One has good hearing, the other has a good sense of smell, so together they're better at detecting the predators. And hopefully in terms of symbiosis of testing, between testing and analytics, we want both of us to benefit from the relationship. In terms of software then, we have sources of feedback. We have feedback for our software, we have feedback on our testing, and we have feedback on our development, which is part of the overall process. And the feedback comes from various sources. So it can come from our applications, and it can come from our fixed bugs. I assume that many of you have actually tested software. Is that fair? You've filed bug reports. You've filed lots of bug reports. Every bug report you filed was fixed. No, never mind. I've worked in many large companies, including Google and eBay, and the typical pattern emerges across all companies. We file lots of bugs. Perhaps we have 1,000 bugs that are open on our system. In about 12 months' time, the project manager comes back and looks at our bug reports and says, there's still 800 open. These are old bugs. They're probably not valid anymore, so let's just close them all. And if the problem comes back again, we'll go and reopen the bugs. But from now on, we'll fix all your bugs. And then we move forward another year's time, and guess what happens? The same holds true. We just have all these open bugs. We eventually just close them all as unable to reproduce, not valid anymore, whatever, and we move on. So if our testing is that good, then how come most of our bugs don't get fixed? And where do we get our feedback from, and how good is that feedback? Because how do we get feedback from our applications, for instance? So the next thing is, what is analytics? Let me try and describe the term. The first thing is, when most of you visit a website, you may notice there's occasional requests going to Google Analytics. Many of the websites we visit make little calls to analytics and send little messages back to Google. And Google record this information, and then someone looks, and we can see here that right now there's apparently 30 active users on this website. Brilliant. Is that true? Well, it remains to be seen, doesn't it? We don't actually know whether this number's correct. And analytics, according to Wikipedia, is a combination of statistics, sounds like a horrible topic already, computer science, by the time we put these together it becomes a bit of a mess, and operational research. So it sounds all pretty heavyweight stuff, but it's intended to lead to things we can act on. So it's one thing to look at pretty pictures, but unless we can act on the pretty pictures, then it's fairly useless and futile work. So what about analytics then? First thing is, it's actually very common in the web. I would reckon that most of the websites we visit have analytics built in them. Many of them using Google. In games, there's some good papers for you to read. Wired magazine, there's an article called Test, Test, Test. Now they're not talking about testing, they're talking about analytics, they're talking about game development. There's a company in Germany, and every morning at 4:30 in the morning, the CEO gets analytics data emailed to them, so they can look at how their experiments went the previous day. So when they try a new idea out, they always test it by experimentation in production. So that's the standard business practice of these organizations. I don't know if your companies are doing this, but game developers certainly are. And I think it's worth looking at what they do. And in mobile apps, then over half the top 100 mobile apps have analytics built in. So again, if the major mobile apps are doing it, perhaps there's some relevance to what we do. Typically, the analytics is provided by a third party. A third party just means someone else really here. So it's not me, it's Google. It's not me, it's Flurry. It's not me, it's Kissmetrics. And there are tens or hundreds of companies who provide analytics libraries. Now, from our perspective, we want some reporting. So we look at the data, and that helps us perhaps to run our business better. Oh, look, we've got 20% growth. We've got more users in Estonia than we used to have. The analytics provider can make money out of us. So there's a reason that these people provide the software for free, like Google and Kissmetrics. They want money from us somehow. And then they sell on the data to other people. So the data that we generate eventually gets sold on to other people, and perhaps it's used to drive things like advertising. So that's the relationship. And what does the user get from this equation? I assume that most of you got smartphones. Yep. iPhones, Android type things, even Windows Phone we can consider smart these days. So we've got smartphones, we install applications, and we very seldom actually pay for them. And it's kind of an implicit trade-off between the users not paying for an app and us trying to make money somehow, that we're gathering data on what the users do. This morning's keynote was saying, who's the big brother now? Is it Apple and Google rather than the government? These are the people who are gathering all this data and analysing it. This is the topology. I'm using mobile as an example because I think mobile has some more interesting challenges. I'll also talk a little bit about web analytics throughout the talk, where there are differences. So we have a bunch of mobile apps on the left-hand side. They send messages over the network. The messages are collected together, put in a database, and then filtered. And they may be filtered by us. We may say we want to see only the users in Latvia. We may want to see only the users with this version of the web browser, or something else we're looking for. So we filter the data, and at this level we're not intended to see who the original individual person was. It's all aggregated statistical data. And we go and look at this in a web view. Typically go on a website like Google Analytics, look at results, get pretty graphs. And that's how a business runs the business. You go and talk to your marketing people, they're already doing analytics in many cases. So if they're doing it, perhaps it's worth us looking at it. The other aspect is every step can be delayed by at least minutes, and sometimes it's hours and days. So it means we don't get the feedback instantaneously, but perhaps, what is it now? It's 4:48 according to my watch. So I may be getting the data from about lunchtime, coming into my graphs and into my systems. So we've got a bit of a lag, but something's there. The way that analytics works is our software sends events. It sends little messages, and the messages go from the mobile app or from our web application to a library, and then they're sent over an internet connection to the analytics collector. And we may have a one-to-one relationship. So each time we send one message arrives at the collector and into the database. Sometimes we send many messages, and one is sent by the library. And other times, our library sends them by itself. And this becomes particularly relevant because these are the messages where they're gathering things like, this is an Android phone and it's a Galaxy 2. And it's currently got the language setting set to French. And other data like that. And when you go and look at your graphs and say, show me all the Android phones where we've got using our software in French, we didn't write that software that got the information. It came from the library. Analytics is often linked to experiments, and we've got two broad categories of experiments. We've got A/B experiments, and we've got what's called multivariate experiments, where we're changing many parameters at once. For those of you familiar with context-driven software, then you may have heard of terms of OFAT and MFAT, one factor at a time and many factors at a time in terms of testing software, where we say we're going to change just one thing. We're going to change the color, but leave everything else the same. We're going to change the number of users, but leave everything the same. And sometimes we deliberately change many things at once and see the impact on the software behavior. Again, there's another Wired article about doing A/B testing. The next couple of slides are courtesy of Keith Stovey. He was a very long time Microsoftie, now working for TiVo, and a lot of his publications are available online. So I encourage you to go and look at his work about testing in production. And here's a couple of slides. The first one on a controlled experiment. This is an A-B experiment. The idea is we have a control group and we have an experiment group. So this part of the room might be the control. We leave them the same. No changes. We're going to change what we do for you lot. So you're the experiment. We run the experiment, perhaps we run it until the end of tomorrow, and we then look at the outcomes. What we want to know is, was the experiment valid? Was it something you can trust the data? And then we separately decide, okay, the experiment seemed to be valid. Did it tell us something useful? Did these people prefer what they got, or did these people seem to prefer what they got in the experiment? So we've got two parts, one left the same, one that we change. Here's an example of an A-B test, and in this case, what we've got, I've been told not to move too much, so otherwise I'd point over there closer. So we've got a page on the left and a page on the right, and what they've done is flip the order of the sign-up button and also change the colour from red to green. And they divert roughly 50-50 of the traffic between the two of them, and they measure the differences. And here we can see that on the left, with the red sign-up, we've got 1.2% of the users clicked through. On the right-hand side, we've got 2.8% of the users clicked through, and we have enough data to make this statistically significant. So we say, is 2.8 sufficiently better than 1.2 to be worth doing something about it? Well, it's more than 2 to 1, so yes, we'd probably change our website to have the green sign-up on the left. Our next experiment might be just to change the colour and see if the colour is important or not, or to change the size of the text and see if that's important, or to change the label and see if that's important. So these are all little tests, and we're running these tests all the time, and typically we're doing this in production. So it's slightly different from the testing perhaps you've been used to doing in the past. And companies such as eBay, Google, Bing, are all testing in production. Facebook, this is standard engineering practice for them. So the nice idea of having testers test the software before it goes live. Yes, there may be a bit of that done, but much of the testing is actually done in production and based on the data that they get back from it. So what sort of things can we measure with analytics? See, here are some examples where I think you can help inform us on the software quality, so how good our software is and our application is. We can look at things like performance. At a simple level, how long do activities take? Is it 1 second, 2 seconds, 3 seconds? We can look at resource consumption. The question mark afterwards is because I'm not sure we should be monitoring the resource consumption on the device. If you're looking at a desktop computer or a mobile device, it can be particularly important looking at CPU utilization. And if the computer's busy, then our software may be running more slowly. And it may be busy because of our software or because of something else that's happening on the device that's also eating the CPU, and we may need to change the behavior based on that. The next thing is reliability. As we know from testing, we may be able to use this function once and it works. We can use it twice and it works. But how many of us test something 1,000 times, or 10,000 times, or 1,000,000 times? But effectively, our user population do this all the time for us. They're the ones who are using our software, and they're the ones experiencing the errors. So do we know what the error rate of our software is today in production with our users, whether it's mobile clients, desktop clients, or websites? Well, we can gather this data, and we can measure reliability in two different ways. Mean time between failures, looking at clock time. So when was the last failure that occurred? And the probability of failure on demand. It's a bit like when we go up to a cash machine, an ATM, we put our card in, and we want to use it to perhaps get some money out. Does it fail when we turn up and try to use it? And if so, how often does it fail? Is it every time I turn up? 1 in 10, 1 in 100, 1 in 1,000, 1 in 1,000,000. So that's what probability of failure on demand measures. Two different ways of looking at the same equation of reliability. And then for usability, imagining a multi-step process. Step 1, fill out your username. Step 2, fill out your address. Step 3, put in your credit card details. How often do the users get to the end of that process, and how often do they complete it successfully? Can we measure that, and is that useful to us in terms of understanding the usability of our software? But we need to be able to calibrate our use of analytics and the analytics that we're using. And calibrate means we're aligning with it and trying to get closer to the truth. So we need to calibrate the tools, the libraries we're using, the systems and services we're using. We need to understand better what analytics is telling us, and we need to calibrate our practices, which is how we're actually using it. Here's two examples of the implementation options for analytics. On the left-hand side, we've got mobile and desktop. So this is Skype for Mac. This is software running on my Android phone or Windows phone. And the way that it tends to work is the analytics library is built into the application. So it's compiled and becomes a single unit of code at runtime. On the right-hand side, we've got a web page. And in web pages, we either use JavaScript or these 1 pixels, which aren't visible on the screen, but the request to the server saying, please give me this 1 pixel image is recorded. And that's the important thing. The request, not receiving the pixel. That doesn't matter, it's sending the request. It's logged by the server, and that generates the analytical data. So with the mobile and desktop, the library lives inside our application, and it becomes a first party. It becomes part of our code as if we'd written it. And it has equal rights to everything that our code has. So if our code has access to contacts on a phone, then so does the analytics library. On the web side of it, it's permission-based. Now, many of you use the web, and you see these little pop-ups that say, do you agree to us using cookies? The reason these websites ask it, and they ask it the world over, even in America and the Far East, they ask these questions to users, because the EU law is so strong for the cookie law that everyone around the world is paying attention. Admittedly, the implementation is poor in terms of the dialogue. The intent is that users should be able to control what's happening. So that's why we have these little pop-up dialogues that say, please agree to use cookies on this website. We can choose to block cookies. We can choose to block traffic to third-party sites, which are things like advertising. So the user is in control, and the user implicitly gives permission for these requests to go to the server. So if you're using Google Analytics on your website, and the user blocks third-party activity, that traffic doesn't get sent. So the user is more in control, whereas with the application, the user isn't in control and can't block the traffic that's being sent by analytics. And this software also has its own life. It has code in there that runs independent of what we're doing. So when the application starts up, the analytics library will send a message back to the server. In that message, it may have lots of data about the device or the computer system it's working on. And this data becomes relevant. When companies use analytics, the typical process, and perhaps your company is different, is you pick a library, you try it, you make a couple of calls, you declare victory and move on. Very few people actually look inside the library and say, what's it doing? Can I trust it? And as important, what else is it doing that I'm not aware of, I'm not paying attention to, that might be material to me in terms of the software I'm working with? And we need to know whether we can trust and rely on that library. Is it accurate? Is it authentic? Does it work correctly in all the different permutations and situations that we need it to? So to give you examples from a mobile perspective, what happens if the phone is in flight mode and I'm playing a game? Where do the analytics messages go? You're just cutting out a little bit. Can you hear it or not?
It's okay.
Are you okay with that? Yeah. Okay. So we need to look at the offline behavior. Also, the libraries have access to sensitive data, and there's a fair amount of security research done by universities that finds that about half of the analytics libraries copy data that users would deem to be extremely sensitive information, down to things like a phone number, and it's just copied automatically, sent by the library without us paying attention to it, and gathered. And remember that we're dealing with a third party who sells that information onto a third party. So the data that's being gathered, the moment I start the game up with analytics libraries, it may be sending off details that are very sensitive without me even having played the game, or whatever piece of software is that we're running. Again, this morning, one of the things that we're discussing was human ethics and behaviors. So this is something we need to look at. How many resources does it consume? Again, it turns out some of the libraries send messages every 15 minutes, regardless of what the software is doing. So do you really want your application to be sending messages every 15 minutes, even when it's idle, because you're using someone else's library? We need to look at how easily we can control the behavior of the library. Can we tell it to slow down? Can we tell it not to send some messages in terms of us using it? And of course we need to be able to implement it. We need to be able to combine it with our software and use it for something useful. And finally, I think, to be honest to our users, we should tell them we're using libraries that are gathering data about them and their devices, them and their computers, but very seldom done. Next thing then is looking at validation and verification. So validation simply, is the analytics software useful to us? Are we getting data that helps us to do something with it? And for the users, is it useful? For the business, is it useful? For the third parties, is it useful? If it's not useful to some of these people, then we may need to rethink what we're doing. And then we need to make sure it does what it claims to be doing. So when we look at the pretty graph that says 30 users are active right now, is it really 30? Maybe it's 50, maybe it's 10. But many companies base their business model on saying, well, if usage goes up by 20%, we're going to pay you a bonus. Brilliant. What they're using to measure your bonus, someone else's software, that we haven't actually checked whether the answers are correct or not. One of the companies I work with used 3 analytics libraries. They used to use 2, and they found that the results were different often enough. They had to have a third one in to be the arbiter. So if they were lucky, 2 of them went this way and 1 of them that went that way, so they trusted the 2. But they didn't all consistently go the same, so sometimes they had to rely on the other ones and fiddle the numbers round. So it's that sort of behaviour that's so different that we can't just say, I'll use any library and off we go. But if we're not testing this at the beginning, at the outset, it can cause us problems later on. Some potential pitfalls for us then. I'm quoting from the Universal Declaration of Human Rights here, Article 12, which is saying that no one should be subject to arbitrary interference with his privacy. This software can be capturing all sorts of data. So, are we conforming to the Human Rights Act? This is a real example. This is Kissmetrics. The URL's at the bottom, kissmetrics/y. And it says, we help you to know your people. If you look carefully at the top right-hand side, you'll see it's got an example of a named individual. Now, the idea of analytics was supposed to be that it's statistically based, and you couldn't work out who the individual is. These are commercial libraries saying, well, don't worry about that. We'll tell you exactly who your users are, and how much money they're worth to you, and how old they are, oh, and where they live. Anything else you want to know about them? Sure, we'll get that for you. So we've got to be a little bit careful, and if your company is saying, let's put analytics in our software to measure the business, then perhaps we should be factoring this into our testing as well. Some other potential pitfalls is fidelity. Correlation, at least to me, means that when this thing changes, does this thing change too? So if this goes up, does that go up? Roughly in line with each other. This one may go up more, like this, but it's looking at whether the change is consistent. So when it says that we've got 15 more users, does it actually reflect that in the graphs? We need to look at consistency of the libraries. Can we trust them consistently? And many of the analytics libraries are inconsistent in their behaviour. And given that we're often relying on the data, that's important to us. And are they reliable because they have bugs in too? One of the biggest problems of using analytics library is if you decide you want to change the one you're using. I started using company A, realised it isn't quite working for me, perhaps they decide they want to charge a lot of money for that service, I'm going to move to company B now. Well, the first question is, who even owns the data? Is it your data, or that little click-through agreement when you downloaded the API for their tool says basically we own the data, and you don't have access to it unless we put it through our pretty graphs for us. So we need to look at that, and then changing the measure. And this is one of the reasons why this company ended up with 3 analytics libraries. They didn't remove one because it affected how they measured their business. They knew it was wrong, but they were still frightened to remove it. Because if that was the one they said, well, we want to see it go up 10%, they wanted to compare with 3 months ago. And if they removed the library, they had nothing to compare against. So you need to look at the separation. And in England, the yardstick is similar to a meter. So it was actually measured from the king's nose to his thumb. So the idea was it was roughly consistent until the king died. And the next king came along, and he's a different size, so he's like you, a bit shorter, perhaps got shorter arms. So the yardstick has now changed. So the same holds true with analytics libraries. We swap from one to the other. We're not measuring like with like anymore. So now I've explained a little bit about the background of analytics, I'd like to cover how we apply the concepts. The first thing is we start by designing the events, the little messages that are going to be sent. So what is the information that we want to gather, and how can we make sure we gather the right sort of data at the right time? So for instance, do we want to log that someone started the application? Probably. Do we want to log that they signed into the application correctly? Probably. Do we want to log that they had a problem signing in? Perhaps. So we may want to keep track that someone's tried to sign in 7 times, and on the 7th time they're successful. Does that seem like reasonable data to collect? Probably. We don't want to send the passwords over they're using, of course, but from an analytic perspective, if we see that users on average are taking 3 login attempts, perhaps that's telling something about the usability of our software. So that sort of data can be useful to us. So we then implement it. We pick a library, we write the methods, we call the methods, and we measure the results. From a testing perspective, if you pick up any analytics library and you write a little bit of software around it, you and your team, then the first thing I would do is say, okay, I've logged in. Do I see a record at the other end? The website, is the record there? Yes, I can see that 1 active user is on the system. Good. What happens if the 2 of us do it together? Oh, 2. Yeah, that's pretty good. 1, 2, 3, 4, 5, 6. Yeah, 10 of us. 10 of us in the team. Let's all log in together. Do we see it's gone up to 10? Well, if it's done the 1 to 10 correctly, chances are that I'll trust it to do 11 correctly and 12 correctly. And hopefully, when it says we've got 153 million active users, we've actually got something close to 153 million, not 17. But if we don't do that test, then good luck to us. And then we assess what progress have we made. Is this useful to us? Does it tell us enough? Do we need to change anything? Do we want to replace the library? So it's a bit like agile development where we do a retrospective. And then we iterate on this process and refine it. Here's some suggested assessment criteria for using analytics. I've given them colours. I'm not sure if the colours are that useful, but this is modelled on something called the 6 thinking hats, which is work that's been around for about 30 years, and is a way of looking at directions of thinking. If you're interested, look online and you'll find some of my material and other people's material on this work, but it way predates me. Yellow then is looking at the best possible outcome, the sort of sunshine, and it's saying what are the benefits of using analytics? Is it giving us useful benefits? White says, is it safe to use? Can we trust it with our data? Can we trust it with our users' data? Purple is looking at fidelity. So do we actually trust it? Is it true in its behaviour? Red, what about the feelings? Let's imagine that you realise now that you're using this beautiful application on your phones or on your computer, and it's tracking your phone number and sending it off to third parties. How do you feel right now? Happy? Elated? Pleased that you can get a phone call at 11 tonight from a company offering you free holidays in Tallinn? Probably not. I've repeated white actually, so I apologise that one. Green, then the eco rating. So how many resources does it consume? Is it minimalist? Remembering that it lives inside our application often, and that means that any messages it sends, any CPU it uses, reflects badly on our application. And the last one then, the black side of it, is looking at the problems and privacy and risks. So we've got the analytics. This work is actually from Microsoft Research, and it's looking at analytical questions and how it can look at the past, what's been happening before, what's happening right now, and hopefully predicting the future. And it gathers the information, and we use that information to get insights. So in terms of the past, well, trends in defect reports. As testers have been involved in a project for long enough, there is a trend of what's happening with defects. We can look at the analytics and that and say, well, actually, we're increasing the bug count. Does this mean something to us? Do you want to change what we're doing as a result? Do we need to fix more of the bugs? Are we filing bugs people are ignoring? Perhaps we shouldn't bother doing that testing anymore if no one's going to fix the bugs. Does it really matter or not? So we can ask the root cause analysis based on the past experiences. In terms of the present, you can look at the concept of alerts. If I get an alert saying something's happening more or less right now, perhaps it's an hour or two ago, saying, hey, we've noticed this trend is happening, can we respond to that trend? Perhaps it's adding more servers to our production environment. Perhaps we're noticing that the bug count has gone up suddenly. Why is the bug count going up in the real world? Maybe we should investigate that and do something about it. And hopefully we can predict the future. We can extrapolate and say, based on what we're gathering in the analytics, we've noticed that our system's growing by 5% a month. We need to plan for that growth for the rest of this year. So we're using it to predict the future. So this is an iterative model of improving our development workflows and our testing workflows. We have a mobile app, and inside there's an analytics client which is sending the messages. We gather the analytical data, which is down on the left-hand side, and we also get data from our testing. We file bugs, and we keep records of the testing we're doing, and we can compare the two of them. That gives us an idea of the potential problems in our software, given that not everything we find is a real problem. Again, this morning's keynote said there's sometimes reasons to leave bugs in software. We can also get the patterns of usage. How are users using our software today? Does that help us inform our testing? So, an example for you is then when you notice your users doing something like they're navigating through the application this way, they click on this and then they're picking search by name, then they're filtering the results. Perhaps we weren't doing that in our testing before, so we want to start changing our testing to model what the users are doing to then find the problems earlier, rather than having our own way of doing it. And ultimately want to improve the software, and we release the next version. So in this case, on the right-hand side, version X+1, and we iterate and repeat this process. So we're getting feedback on the application, feedback on our testing, feedback on our development, and we can use this to help improve what we're doing. So in terms of looking at how we can measure our testing, then one of the things that analytics libraries tend to do is capture crash reports. It's a sort of added feature they add to the library. And when we get the crash reports back, we can see what's happening in production in use with our software. And that information can say there's problems that we didn't find. Hopefully we didn't find the crash and leave in the software, or perhaps we found it and thought it was a very minor issue, but we find actually it's affecting 15% of users in Estonia. Does this matter to us? Well, if it does, we want to react to it. In terms of usage patterns then, how many of you use personas? A couple of you? Okay, it's one of the things that Microsoft relies on a lot in their testing. So they model individuals. So, forgive me, but I'll model a young man with a European background here, and he's the sort of person who doesn't use technology very much. So whenever he uses a mobile phone, the first thing he has to remember is how to operate the phone and turn it on again and look at the screen and check something. And I might model it on, forgive me, but a young mum, and say, well, how would a young mum use our software? So we can build the personas based on the data we're getting from the analytics libraries. We can look at the navigation through the software. We can build functional test cases based on the data that we're getting. The example I have is localization testing. Multinational company, and they're based in London, and guess which language they test all their software in? English. Why wouldn't you test in English? And one of the testers was looking at the analytics data for the first time and said, hey, all our users are in Paris. They found that basically they had a vast number of users in Paris who are using software right now, but guess what we hadn't been testing? We hadn't been testing the French locale. We hadn't been testing the French language version of the site. So we realized it was more important to make sure we had tests in French, to make sure the French side of it worked, because that's where our users were. So we're able to reflect what's happening in real life back into our testing to improve our testing. And with analytics, we can also increase our use of experimentation in production rather than just doing testing. Sometimes, from a business perspective, like Facebook has no testers at all. There's no one who has a job title of testing in that organization. Instead, they do everything in production. So that's where they get the data from and decide whether the software is working or not. So the symbiosis between testing and analytics then, the first thing is to know whether we can trust the libraries we're using. So who checks that the libraries are correct? And the second thing is, once we've got this confidence in the software, we can then use the analytics data to better understand how our applications are being used, and hopefully to find problems sooner. At the beginning of this talk, I mentioned about the feedback coming from our users. Well, feedback from users is very sporadic and tends to be very late. Most of our users don't tell us what they like and don't like about software. Analytics gives us a better channel to them where we're getting data more or less in real time about how you're using the software. And from the crash logs, we're also seeing what's happening in terms of our software failing. So it gives us the information sooner so we can fix the problem sooner. Ultimately, that means that the users get better software and hopefully everyone's happy. In English law, one of the things that you swear to do when you give evidence is to give the truth, the whole truth, and nothing but the truth, so help me God. This has been around in English law for about 800 years. And in terms of analytics then, we want our library to tell the truth, the whole truth, nothing but the truth. So we don't want it doing its own thing. We want to be able to rely on it and trust on it to be able to inform us and use their data accurately. And consider the benefit to every stakeholder, particularly the end users. Because if we forget them, there's a risk of a backlash from them. And as Jerry Weinberg says, quality is value to some person. So all we're trying to do is find ways to improve the quality of the software for some of the people involved in using the software. When I was introduced, you mentioned I'm an author. I'm actually involved in 4 main books at the moment. The first 2, these are collective works with multiple authors. This is a development book, and I've got 3 physical copies here for people who want them. The PDF's available online. It's updated 2 or 3 times a year. So if you're interested in developing mobile apps, we cover it there, and there's a bit of on analytics there. The second book is a purple book. It's a marketing guide. So much greater focus on using analytics to run a business from a business perspective, but it's written for people involved in the mobile industry, including programmers. So how you market your apps. My old testing book is the third one. Don't buy it unless you're feeling very generous. It's quite dated now. And the book that you can have a copy of if you ask me for it is the 4th book, which will be published this year. And all I ask you to do is email me, agree in the email you won't share or forward the book, because I'm under contract with the publisher for them to publish it, and I'm happy to send it to you in return. It's about 150 pages long on mobile testing. So that might be useful, and I've got some more information on analytics there. So if you want to know anything more about analytics, then please get in touch, and I'll hand over to questions now.
Thank you, Julian.
So every large company has internal software. Some of it they write themselves, some of it they're buying it from other people. But let's assume that you're responsible for writing that software. Then you can use analytics to get patterns of usage. For instance, when is our system being used in a company? And I don't know which company you work for, but let's pretend you're a national company. So you typically start using your software roughly between 8 in the morning and finish roughly at 6 at night. That's what we think is happening. But if we add analytics, we can see when the software is actually being used. And it may be that you actually travel internationally and you use this system for HR when you've got a chance to file your holiday request, and it happens this week you're in Singapore. So you're many hours ahead and you're actually trying to book your holiday at 11 at night, local time. So the analytics can help us get patterns in terms of the time that you're using the software. Furthermore, you can build patterns of how the software is being used. And one of the challenges, and I think I contradict this morning's keynote speaker, I actually care a lot about the quality of internal software, because ultimately human beings have to use this rubbish. And hopefully it's not rubbish. But companies who say, well, it's only for internal users, you don't need to make it smart, we don't need to make it usable, we don't need to worry about this, that, and the other, well, I think you're missing a trick, because happy people who enjoy what they're doing, then are going to be more satisfied at work. So I'd look at using the data for that. So those are some examples, and I think there's a lot more that one can do. You can use it for capacity planning, so making sure your servers have got adequate capacity. You can look at things like latency. Is the latency of some of the systems like HR increasing? Task completion rate. So are users correctly filling out the forms? Again, this morning's example of the 13 form field to register he was a dad. Well, it was wonderful, they phoned him up. They were probably using some sort of analytics or analysis of the data at least to see that he'd tried and stopped, and tried and stopped, and tried and stopped. And the third day, what the heck, let's just give him a call. And because the government here have the data, they were able to reach him and get in touch and solve the problem. So analytics isn't intended to have the individual's details, remember. It's meant to be statistical and aggregated. But nonetheless, if you see that people have started filling out the form and stop, and don't complete it, then go back and revisit what's wrong with the form. Perhaps phone up some users and speak to them.
Maybe we'll give it a try.
And if you want to get in touch after you've tried it, then by all means email me and I'll do what I can to help.
More questions? I have a question. I'm running a company as well, and I'm very interested in how the users of my product behave. And you mentioned in one of your slides that actually in this metrics, for instance, the central, let's say the object is the persona, the user. And how, let's ask in a way, is it ethical to go into such a detail? Basically, you can watch over the shoulder of every user, because some of these analytical tools enable you to do that. Where do you draw the line? Where would you draw the line?
I tend to lean towards privacy of the individual. And I've worked in corporations and I've resigned from corporations where I believe that the behaviour contravenes what I deem to be ethical. Because ultimately, we are already over-monitored and over-tracked. And I don't think it's necessary for you to know exactly what that person's doing. It might be nice for you to know it, but not necessary to know it. So if you know that half the users can't complete a task, is that enough to tell you that something's worth investigating with that task? Probably. So would it be nice to be able to see what the users are doing? Sure. Well, why don't you get 3 of the users in to a little UX lab and pay them and ask them questions? And then it's honest and ethical and it's face-to-face, rather than tracking them by monitoring their keystrokes. So I'm not saying you would do that, but that's the other extreme. So be open with people and talk to them. In some of the work I'm doing in Africa, one of the challenges is trying to explain the concept of intellectual property and privacy to people who've never used a computer before. How do you explain people to this and say, do I have your permission to take your handwriting and publish it on the internet, which is what I'm doing, by the way. They handwrite reports for me, I get them digitally scanned and emailed to me, and I put them on the web as part of an open data part of the project. So I have to try and get their permission and explain what privacy means. Explains the fact this information is public, and they give me permission. So I think you can do that. If I can do it in Kenya, I suspect you can do it wherever you are.